factorial have? So first of all, what is a trailing zero? How many trailing zeros does this number have? This number has 4 trailing zeros. The number of trailing zeros is the number of consecutive zeros from right to left. Now, the numerical value of 30 factorial, which is calculated by multiplying 30 from 30 to 1, is a number with a certain number of zeros. For instance, the numerical value of 5 factorial is 120. Therefore, 5 factorial has 1 trailing zero. Now, in order to find the number of trailing zeros 30 factorial has, we must apply the following formula. Number of trailing zeros of n factorial, n over 5 plus n over 5 squared plus n over 5 cubed plus etc. n over 5 to the kth power, where 5 to the kth power must be always less than or equal to n. Thus, the number of trailing zeros of 30 factorial is 30 over 5 plus 30 over 5 squared. This is 6 plus 1.2, 7.2, finally 7 trailing zeros. Note that decimals will always be rounded down. Choice D is correct. How many trailing zeros does 250 factorial have? In order to find the number of trailing zeros 250 factorial has, we must apply the following formula. The number of trailing zeros of n factorial equals n over 5 power to 1 plus n over 5 power to 2 plus n over 5 power to 3 plus n over 5 power to k, where 5 power to k is always less than or equal to n. Thus, the number of trailing zeros of 250 factorial equals 250 over 5 power to 1 plus 250 over 5 power to 2 plus 250 over 5 power to 3, and I cannot add 250 over 5 power to 4 since 5 power to 4 is greater than 250, so I will delete this guy. Finally, this is 50 plus 10 plus 2. Finally, 250 factorial has 62 trailing zeros. Choice D is correct. What is the unit digit of 756 times 937 times 513. First of all, what are the unit digits of these numbers? The unit digits are the last terms, 6, 7, and 13. We want to know the unit digits of this product. For instance, 3 times 6 is 18. The unit digit of the product is 8. We need to do something similar in this question. Do we need to calculate the whole product in order to know its unit digit? The unit digit of the product is equal to the unit digit of the product of the unit digits of the factors. Thus, the unit digit of such multiplication would be the unit digit of the products of 6, 7, and 3. 6 times 7, 42 times 3. I take the units again. 2 times 3, 6. The unit digits of this product is 6. Choice E is correct.
It says, what is the units digit of 37 to the 47th power? As in previous question, we don't need to do the whole operation. Since we want to know the units digit, all we need to know is what is the units digit of the last digit, 7, to the power of 47. Okay, and this has a pattern or a sequence. For example, 7 to the power of 1 is 7. The units digit is 7. 7 squared is 49. The units digit is 9. 7 cubed will be equal to 7 squared times 7. That means that the unit digit will be equal to 9 times 7. This is 63. So the unit digit is 3. Remember that we don't need the whole result. We need the units digit. 7 to the power of 4 will be equal to 7 cubed times 7. The units digit will be equal to 3 times 7. And this is 21. So the units digit is 1. And every 4, the units digit repeats. Therefore, 7 to the power of 5 will be 7. 7 to the power of 6 will be equal to 9, and so on. So we can complete this pattern. Now, we should notice something. In the last row, the exponents have something in common. The exponents are all multiples of 4. So we can conclude that 7 to the power of 4 always will have a units digit of 1. Now, a multiple of 4 closest to 47 is 48. So 7 to the power of 48 has a units digit of 1. That means that 7 to the power of 47 has a units digit of 3. And that is the answer.
What is the remainder when 133 to the 63rd power is divided by 10? First of all, remainders are what is left over in a division problem. For instance, 14 divided by 4, quotient 3, and remainder 2. Now, pick any number divided by 10. The remainder is always So I'll pick, for instance, 61. 61 divided by 10 leaves a remainder of 1, the unit digit. I pick another number, for instance, 743 divided by 10. 7 and 4. Remainder 3, the unit digit again. Now, when a number is divided by 10, the remainder is always the unit digit of the number. It means that we need to find the unit digit of the power shown above to get to the answer. Now, does number 3 have a unit digit sequence in its power? Sure, it has. Let's find out the sequence. Three to the first power is 3. Its unit digit is 3. Now, 3 squared is 9. Unit digit 9. 3 cubed is 27. Unit 7. And 3 to the fourth power is 81. Unit digit 1. Now, 3 to the fifth power is 81 times 3. 3 and 243. But the unit digit is 3. It means that 3 to the fifth power is on the first row. Therefore, here is 3 to the sixth power, 3 to the seventh power, 3 to the eighth power, and so on. Note that it's a sequence of 4 different unit digits. Therefore, 3 to the 64th power must be on the last row. And 3 to the 63rd power must be on the first row. So now we know that the unit digit of 133 to the 63rd power is 3. Therefore, the remainder when this number is divided by 10 must be the unit digit 3. Choice B is correct.
you.